Hey everyone, welcome. I know folks are kind of filing in here. We'll be getting started in the next few minutes, but very glad to have you all join us today. We should have had a better little waiting room music going at this point to just kind of get everybody in the right kind of relaxed Hextiles mode. But yeah, seeing folks filing in now. All right, hey everybody. I know folks are still kind of filing in. We're going to get started in about 1 minute, but thank you all for joining. We really appreciate getting to have a little crowd here as we are excited to talk through kind of a new launch from the Unfolded team. So as we just wait for folks to join us, we're going to be, having about 30 minutes or so of a presentation, and then we're going to leave a little bit of time at the end for Q&A. We'll talk through that a little bit more, but you can already kind of start percolating on what questions you might want to ask. And then after that, we're going to invite everyone to a fireside Slack chat, which is kind of the first time we're doing it, but to just sort of allow for a little bit more discussion after the webinar in the Unfolded community Slack. So I'll explain that all in just a minute, but welcome to everyone who's kind of filing in. All right, and I guess we are now officially at start time, so I'll go ahead and kick us off. So welcome everyone again. My name is Miriam Young. I'm a product marketing manager here at Foursquare. It's really nice to have so many of you joining us today, and as you are likely aware from the invite and all the reminders, we're going to be hearing today from Senior Staff Software Engineer Nick Rabinowitz, who joins me, and he'll be talking through a brand new spatial analytics technology from the Unfolded team. It just launched earlier this month on February 16th, called Hextiles. So I will let him talk more about that. But I just wanted to explain a little bit some housekeeping items. So we definitely want to hear from all of you in today's conversation, and we'll be leaving time for questions at the end. So in the meantime, you should see that you have kind of like a little panel probably on your right-hand side where there is room to kind of enter in questions. And we'd love if you could just be entering questions in kind of throughout the webinar. That will allow us to have kind of a nice cue to kick off with once we get to the Q&A section at the end. So please send questions throughout as we go, and then we'll make sure at the end to have time for that. After the live webinar wraps, we're also going to invite everyone to join us for a little webinar after party, if you will. So at 2 p.m. Eastern, so immediately following this, we'll post a invite basically for folks to join us in the Unfolded community Slack. So it's essentially a Slack channel where we're going to just open up for any other questions, any other discussion that folks would like to ask. It's kind of like if you've ever seen like an Ask Me Anything type, online discussion, it'll be sort of like that, where you can chat directly with Nick and kind of ask any other burning questions you might have about Hextiles, Unfolded, anything at all. So I'll post a link to that in just a moment so you have that handy. But with that, I will leave it to Nick to take it away from here, and we'll see you kind of back in the Q&A. So thank you again.
Thanks, Miriam. Hi, I'm Nick, and I'm here to talk to you about hex tiles, Foursquare's next generation tiling system. So just a quick overview of what we're going to cover in the webinar today. I'll give you a little bit of an intro of myself and of this new technology. We're going to talk a little bit about the H3 library, which is the technology that hex tiles are based on. And then I'll talk about the hex tiles themselves, how they work, and why you might find them interesting. And we'll do a few little demos. I'll do a demo of how to work with hex tiles in Unfolded Studio. I'll go through a little bit of a case study of how you might use hex tiles for a site selection use case. And then we'll have Q&A, as Miriam said. So, hi, I'm Nick. I'm Nick Rabinowitz. I'm at nrabinowitz on most platforms. And I'm a senior staff engineer at Foursquare. I've been working on this hex tiles project for the last year or so. Before Foursquare, I was at Unfolded. Unfolded eventually became part of Foursquare. We're now part of the Foursquare family and happy to be there. And before that, I was at Uber for about 5 years, working on geospatial analytics systems. And before that, similar work as a software engineer and a long history with nonprofits and public organizations. So I've been a software engineer for about 20 years, and I've spent about the last 10 years in mapping and data visualization. And I'm also the core maintainer of one of the core maintainers of H3 and the core maintainer of H3.js. So I've been working on the H3 project for quite a while now. And partly because of that, I really love hexagons. Secret about me that's not so secret, I love hexagons. I mentioned that Unfolded is now part of Foursquare. We joined the Foursquare family in this past summer. The way I think about that merger, and this is just my gloss, don't take this to your business analyst desk. But I think of this as, Unfolded was a data analytics company with no actual data, and Foursquare is a data company that at the time didn't have a data analytics product, and put us together, and I think we can do some great things. Hex tiles I see as one of the first examples of where this really fruitful collaboration can lead, where we can take Unfolded's data analytics prowess and put it together with Foursquare's data and make something really unique and special. The challenge that hex tiles are trying to address, and the challenge that we're generally trying to address at Unfolded and now at Foursquare, is this challenge of geospatial data. The world runs on these huge amounts of geospatial data. We're generating data all the time from our devices, from our, the Internet of Things, from all sorts of sources now, and it's very difficult to work with. It has both geography and time, and we need to visualize it, be able to understand it, bring it together from different sources. How can we do that when the data sets are usually very large and in some cases very unwieldy? Well, one answer, and an answer I'm very fond of, can be found here in the humble hexagon. And I'll talk a little bit more about why hexagons are so useful here. I had a whole separate presentation on why hexagons are perhaps the best regular polygon. I won't go into that here. But I do think that it's a very powerful tool for doing geospatial analysis, particularly when applied to the world. So we can take hexagons, we can lay them on top of a world map, we can lay them on top of the globe, creating this grid system we can use for analysis. So this is an example of a geographic grid system. This is also known as a discrete global grid. And what a discrete global grid does is apply this common abstraction to the entire world. So we divide the entire world up into these uniform cells that moves everything into one common unit of analysis. And there are a lot of benefits to this. Obviously, it's an abstraction. You lose certain things, but you also gain a lot. One of the things you gain is the lack of bias. So if you try to use, administrative boundaries or zip codes or states or things like that, these are heavily biased by human history, in some cases by natural landforms, in some cases by legislation, things that actually may make no difference to your actual data analysis. So they don't always work as a good unit of analysis for your particular use case. But a uniform grid system allows you to work with this very clean mathematical space that doesn't have these biases. And that space also supports kinds of algorithms that are hard to do in a more traditional geographic milieu. I say grid systems and not just a grid because one grid can cover the entire world, but usually a grid system actually has multiple levels. So in this case, you can have parents and children that either perfectly or imperfectly aggregate up into each other. And you can look at multiple series of grids that allow you to look at both coarse data that has been aggregated up to a high level of abstraction, and fine-grained data that really works at the local level. There are numerous grid systems. Well, okay, there are a few different grid systems. The one that I'm going to talk about here, and the one I think is, well, the one that I think is the best because it's the one that I work on, of course. But I think one that has some claims to being the best grid system is the H3 grid system, which is based on hexagons. And you can see here there's a sort of brief visual breakdown of how the system's constructed. We take an icosahedron, which is a 20-sided shape, a D20 if you're familiar with multi-sided dice. We lay it on top of the globe, and then we take each face of that icosahedron and we break it up into hexagons, or in some cases half hexagons. And then we subdivide and subdivide and subdivide to get different levels of the grid. And this gives us a global grid that can work at a very coarse level, where we have 122 coarse cells at the top level, all the way down to cells that are about a square meter. So you can index anything in the world very quickly into a unique hexagon that you can refer to in your data analysis. Just briefly talking about the H3 library. The H3 library is open source. It's something that I worked on when I was at Uber and that we open sourced, so it's now free for use. Anyone can use it. It's built in C. It's very fast. It's very applicable to many different languages. So Python, Java, JavaScript all have native bindings where you can work with it in those languages very comfortably. And increasingly, there are extensions and UDFs that you can use in your database of choice. For example, PostgreSQL or BigQuery. So it's a very flexible, very low-level system. I like to think of it as a sort of building block for great things. It's not necessarily something you would use right out of the box unless you are a programmer or a data scientist, but it's something that lends itself to many different uses. As I mentioned, one of the things that I think is most important about a discrete global grid system is its ability to bring everything into a common unit of analysis. And that's especially important for geographic data because geographic data comes in so many different forms. Some of our data might come in as raster data. This is basically either satellite images or remote sensing, things that are essentially, images laid on top of the surface of the Earth. It might come in as polygons, like administrative boundaries, census blocks, zip code tabulation areas, things like that. Or it might come in as points, for example, GPS traces or other kinds of point-based data. And these things can be very difficult to unify using traditional GIS. For one thing, you generally need a fairly heavyweight system like ArcGIS to even start to work with polygons. And for another, it's just difficult even on a theoretical basis to bring these different things together in a unified way. What a system like H3 gives us is the ability to use one kind of unified cell and put everything into those buckets. As I've mentioned before, you're paying some abstraction cost here. You've taken this fine-grained data, for example, the exact administrative boundaries, and you've moved it into something a little bit more abstract. But that abstraction gives us the ability to take all of these different things and work with them together. So we can now take one cell in our map and we can say, oh, this has this data from this data set, this data from this other data set, this data from a third data set, when all these different data sets came in different formats and in hard to work with shapes. With that, I'd like to move on to talking about hex tiles, which is the new system that we've built on top of H3 at Foursquare. So as I mentioned, the H3 grid gives us this global standardized grid system, and we can use that to partition data. If you're familiar with partitioning at a database level, it's basically breaking up your data into different even-sized chunks that you can work with more easily than working with the entire data set all at once. So we can use this for storage, we can use this for processing, we can use it for analysis. It turns out we can also use it really effectively for tiling. So you may be familiar with other kinds of map tiling systems. Tiling is essentially a way of breaking up a very large, fine-grained data set or map and breaking it up into different pieces so that you can use only the parts you want at the time you want them. Every web map from the beginning of the web mapping era with Google Maps has used this kind of tiling system to give us the kind of maps we're familiar with today. In the case of hex tiles, we're using this to partition data in a way that both allows us to work with it really easily in a parallel manner and allows us to display it and navigate it really fluidly and effectively on a map. There are actually two different resolutions. When we talk about the H3 grid, we're usually talking about a resolution, which is how big the cell is at a particular level. So resolution 0 are the coarsest, largest cells. Resolution 15 are the finest cells. When we are using H3 for hex tiles, we use two different resolutions. There's the tile resolution, which is relatively coarse and breaks up your data into these manageable chunks. And then there's the fine data resolution, where the individual data points live. So you can see that each of these sort of larger hexagons has many, many, many small hexagons within it. And that's the data resolution. It's essentially the rows in your database or your data set. So hex tiles are a new analytics tiling system, and I'll talk a little bit in a second about why an analytics tiling system might be different from traditional sort of web map based tiling systems. It's developed for faster and easier large-scale geospatial data visualization, as well as enrichment and other kinds of analysis. It's based on H3, as we've discussed. It's specifically optimized for spatial analysis, so you can use partitioning systems in non-spatial contexts, but right here we're really talking about something designed for geographic data. And right now it's this proprietary tile format where we take tabular data sets and encode them into smaller and smaller tables. Each one is a tile, and each of these tiles can be brought together on a map or in other analytical processes to work with them individually. So why would we create this new system? Hex tiles are addressing some of the biggest pain points that we've seen as geospatial experts that we've seen in geospatial analysis. The main thing that hex tiles address is the size of the data set you can work with. So the unfolded system is actually very good at working with relatively large data sets and working with them in this very fluid, interface where you don't have to particularly code, you can do everything through the UI and you can move around the map very easily, but it has a limit on how large the data sets can be in most cases, because in many cases we're actually bringing all of the data into the browser for fast analysis. So it's very difficult to do that when you want to work with a database that might be several gigabytes or even more. In order to support these large data sets, you need to bring only the pieces you care about into the browser, and that's where tiles come in. And hex tiles allows us to easily pre-process and store these very large data sets you might want to work with, and then bring them into the browser only as and when needed in a way that allows for very fluid exploration. Because it's based on H3, it's also really good for unifying different data sets. So as I mentioned, you can take a variety of different geographic inputs and move them into this common unit of analysis using H3, and then you can put them together in a way that allows you to do analysis across data sets that would otherwise be difficult. As I mentioned, one of the key benefits here is data visualization. You can visualize these data sets at interactive speeds. So instead of sort of waiting for something to render or waiting for a long database query, you can easily move around the map and look through the data both at a coarse and at a fine-grained level. And we've also extended this geographic idea to handle temporal data. So tiles can have a time dimension, and you can look at data that changes over time, which is something quite difficult in other tiling systems. So if we look at some of the other tiling systems you might be familiar with, there are raster tiles. Satellite imagery is probably the most commonly used of these, this kind of tiling system. Raster tiles are very efficient at encoding data. They're really good for getting sort of ground truth remote sensing data. They're the actual pictures that were taken by the satellites, but they can be very challenging to work with unless you're a computer scientist. They're joining them with other data is very difficult in general, and it can be, you know, a challenge unless you have specialized tools and knowledge to even start working with these beyond simply looking at them. Vector tiles are increasingly used in web mapping products, and they're very precise. They're showing you actual polygons, so you can encode specific geometry really well. They're really good for navigation. Anytime you are looking at, you know, a routing app on your phone while you drive, you're usually using vector tiles. They're showing you the roads, precisely where they are. But again, the joins are extremely challenging. It's very hard to unify these vector tiles with other data sets to get meaningful information out of them. Hex tiles are making some compromises, like all systems do. The main compromise that they make is they're bringing everything into this standardized H3 geometry. But that allows you to encode many different data points onto one tile, and allows you to easily join them with other data sources and bring them together in a way that allows you to do cross data set analysis much more easily than these other tiling systems. So we think of this as an analytics tile, where we think of the raster tiles and the vector tiles much more as presentational, unless you are, you know, really a data scientist and able to work with those at a large scale with computer vision technology or other approaches. As I mentioned, hex tiles can also support temporal data. So because we're basically dealing with a tabular system in the tiles themselves, we can have this extra temporal dimension, and we can then use that to either animate and display it, or to join it with geotemporal data sets, or to do anything else that you'd want to do with time that you can't just do with space. And I think this is increasingly important in our world of geospatial data, because most of the geospatial data that we work with these days isn't static. It's not just a map that changes infrequently. It's events or device traces or routes, things that change quickly over time, where the time dimension becomes more and more important. So you can do this with some of the other data sets like raster data sets, but generally you have completely separate tile sets, and it's not something you can easily bring in and animate or even bring in to do joins with. I want to do a quick demo so you can get a flavor of what this feels like in practice. I'll switch over here. This is Unfolded Studio and an exciting blank map, like a blank canvas for us. And what I'm going to do is I'm going to start adding some data to the map. I'm going to go into our data catalog, where we have a bunch of our new hex tile data sets that we've recently released. The one that I find most useful in general is this census data set. So this is from Census 2020. It's just the population data set. It's fairly, you could think of population as extremely boring data, but in a lot of ways, it's one of the most useful data sets that we work with when we're working with any other geographic data, because you usually want to know where people live, what kind of people live there, you know, and what can we say about the areas beyond our just general knowledge. What can we actually use data to find out about the different areas of the US? So obviously this is US Census, so this is US only. We can do hex tiles that cover the entire globe, and we have some of those in our data catalog. And you can see we have this, you know, full US, what I think of as a coarse version of the census data, quickly available. But as we zoom in, we can get finer and finer data to load on the map, and we can see an increasingly fine view of this same census data. So instead of just being sort of relegated to one resolution, we can get a resolution that matters to us. And as we zoom in, we get finer and finer grain. As we zoom out, we get a coarser but broader view of the data that we are interested in. So you can see this works pretty fluidly without having to do additional queries, without having to do additional work. It's very much like the web mapping systems that you might be used to when you're looking at, Google Maps or other, image-based maps. But instead of images, we're bringing in data that we can use for analysis. To give you a little bit of a flavor of what we might want to do with it, there are two main tools that we allow right now for hex tiles. We're building more. The first is that we might want to extract some of this data and work with it separately like its own data set. So if we take some of the drawing tools here and we create a new rectangle on the map, we can extract that data into a new data set. I hit confirm, I extract it. And very quickly, I have all of the data available from this box that I drew as a new extracted data set that's saved to my data sets in Unfolded Studio. And I can do anything that I would normally do to an in-memory data set to this extract. And I can save it, I can download it for offline use, or I can join it with other data sets more easily. So I'll hide that for a sec. The other thing that we usually want to do with hex tiles, let me get rid of this rectangle. The other thing I usually want to do with hex tiles is I want to enrich my other data points. So I might have my own data sets that have some geographic component. In fact, usually I do when I'm working in Unfolded Studio. And I want to get hex tile data together with my data sets so that I can do some further kind of analysis. So I already had a data set on this map of 4 square places. These are restaurants in New York. Each dot here is a particular restaurant. And I might be interested in understanding which restaurants are in the densest populated areas in New York. Perhaps to see where there are restaurants in dense areas or where there are restaurants in sparse areas. Maybe there's some places that are underserved by restaurants in New York, and I could determine where would be the best place to put a new restaurant based on that. So to get the hex tile data into my point data set, this is sort of an enrichment process, but it's exposed in our interface as a simple join. So I go here, I select a join, I select the hex tile data set I'm interested in. I'm going to pick the latitude and longitude of my restaurants. And for now, I could select which columns that I want from the census data set. For now, I'll just keep them all. I'll run this. And very quickly, I come back with the enriched data set, which has all of my restaurant data, and then over here, all of my census data. I hit confirm. And now I have a new join data set with all the rows from my restaurant data set that I can use to investigate other kinds of questions that would be impossible to investigate without the census information. So over here, if I scroll all the way over, sorry, there are a lot of columns in this particular data set. If I scroll all the way over, we can start to see these other columns of census information that I have available in my join data set. And if I go back to the layers, hide the population, I'm going to switch this set of restaurants to use my new join data set instead. And for example, I could filter now on this new join data set, and I could filter not only by the restaurant information, but by the population, for example. So if I start filtering down, I can see where are the restaurants that are in the most densely populated areas in New York. And unsurprisingly, they're right around Central Park. They're down, I don't actually know New York very well, so I shouldn't talk too much about New York geography, but they're in these highly densely populated areas, and maybe are more interesting for my analysis because of that. moving back to the slides, this is sort of just getting at the very beginning of what we can do with hex tiles, but maybe gives you a flavor of how to move around a hex tile data set and work with it. Another thing that I really like to show off here, because I think it's a great use case for H3 and a great use case for hex tiles, is site selection. So just to briefly talk through site selection, there are lots of different ways to do site selection. So site selection is when you want to figure out what's the best location for some new venture, for a new store, for a new transit stop, whatever you want to put in the world. You want to figure out where's the optimum spot to put it. And there are lots of different approaches you can use to pick that optimum spot, but the one I really like is suitability analysis. And I'll have to admit that I like this partially because I'm not a data scientist, but I find this one really easy to understand. So suitability analysis is basically a way of taking a bunch of different metrics, a bunch of different layers of data that you want to bring together. In this case, I'm picking income and proximity to transit, urban development, and you bring them all together by converting them to a common spatial unit, putting them in a common numeric range, 0 to 1. Usually you can do this by dividing by some denominator or coming up with some other scheme to convert every metric to a 0 to 1 range. You join them all together. You weight them, usually based on your business use case. So you say, well, proximity to transit matters a lot to the new restaurant I'm trying to locate. Mean income might matter a little bit less. Urban development matters a great deal. And so you give these different weights, and then you just add them all together. And the addition of all of these is your suitability score. And this allows you to take many, many different data layers, put them together, and come up with a meaningful view of them. As someone who's been working with geographic data for a long time, I like this partly because I get really frustrated with maps where they simply display things side by side and then tell you, look, you can easily see these things and how they relate to each other. It's actually very hard to do that visual join when you are looking at multiple data sets side by side. What I want is an actual join and an actual calculated metric that tells me how these things relate to each other and where they converge. So the little hexagon in the previous slide translates these much larger data layers. The great thing about hex tiles is that it allows us to build and prepare these data layers ahead of time. So from Foursquare's standpoint, as a provider of some really interesting data sets, I see hex tiles as this way of preparing and delivering new data products that you can easily bring together in this sort of layer cake of data that you might use for this kind of analysis. So doing a quick demo with slightly arbitrary layers. Let's say that I'm trying to place a new restaurant in the San Francisco Bay Area. I'm interested in income levels. I want, maybe it's a high-end restaurant, so I want to target higher income groups. I'm interested in proximity to transit because it's so hard to find parking in the Bay Area. I might want more educated people who really understand the food offering I'm developing. And maybe I want highly developed places, so dense urban areas, because that's more the style of the restaurants that I'm putting down. So it's a little bit more time than we have to actually go through the entire demo, but to give you a flavor of it, here are some of the hex tile data sets I'm going to bring together. There's an income data set, there's an education data set where I'm looking at how many people have a master's degree, how many people have a doctoral degree, etc. I'm looking at proximity. So Foursquare has all of these POI data sets, and that show places of interest and their location in the world. And I can calculate this tile set that shows me how close you are to any particular kind of POI. So here we're looking at, I think, rail transit, and urban metro systems. And so you can see how close I am to a transit stop, how close I am to one of these locations anywhere in the United States. And we've done this by sort of taking the location of the original POI and then spreading out its effect a little bit. So you get these these little clusters that sort of decrease as you get further and further from the transit stop. So this is a proximity data set. Back to San Francisco. There are other kinds of proximity. I might be interested in hotels. Maybe I'm really interested in getting business travelers who are going to be staying in hotels, so I want to be close to hotels. And the development index that we talked about before. So this is a data set produced by the US government about land use. These purple areas are the most densely developed urban spaces in the country. And I can add these all together through a series of joins. And once I have them, I can put together those normalized metrics into this site selection score. So this is my if you will, my pre-baked cake that I'm pulling out of the oven, because it's a little bit too long to show you the process of doing all the joins. But what I have now is a site selection score that I've derived from all of these Hextile data sets that I can use to investigate my business use case. So I started looking for, urban areas. I wanted to look for high income residents. I wanted to look for proximity to hotels and transit. All of these things are brought together into a single score, this site selection score. And if I want to find what's going to be the best place for my new chain of restaurants, I can either simply look and see the brightest areas, or I can try to filter. I can filter on my site selection score. I can look at the most interesting areas, and as I filter down, I get the best possible areas for my restaurants based on this imagined set of metrics. So the set of metrics you're choosing here are basically your model, and you refine your model, you change the weights, and you figure out what matters to you most for your business use case. And then you end up visualizing very quickly what the model shows you about where the important spots in your area are. You could identify just one or two locations, and that would be great. But having this entire layer means that you could, for example, take a separate data set of possible locations, lay it over here, and get a score for every one of those locations. Or you can start to look at a variety of different spots. So, maybe downtown San Francisco is going to be the best spot for me. And if I filter all the way down, I'm going to be getting right down to the financial district. But the nice thing about this is it gives me a gradient. So if I can't afford a restaurant lease over here, right in Soma, maybe I can afford one over here, down by Potrero Hill or something like that. So this is sort of the next best option. And it gives me a wide variety of options for my different venue, and a way to see how the trade-offs might work between things like real estate prices and suitability. So hopefully, obviously I only used a few different layers here, but you can imagine as you build out your own data sets, and as you take in Unfolded and Foursquare's Hextile data sets, you can layer metric upon metric here with all the things you care about, and come up with a really nuanced view of what's going to be the best place for your next venture. So hopefully this has given you a sense of what we've built so far for Hextiles. As an engineer, I'm always thinking about what we're going to build next. And here are some of the things that I'm really excited about that are coming soon, hopefully in the next few months. We currently allow you to create your own Hextiles through our data SDK using Python. But in the near future, we're going to allow you to use a UI to create these right in the app with no coding. And you'll be able to bring in your own very large data sets, create your own Hextiles, and navigate them as easily as you can navigate the Hextiles that we've created for you. I'm also really interested in calculating metrics over tiles. So at the moment, you need to join, you need to either extract data from a Hextile data set, or you need to enrich your own data sets with Hextile data in order to calculate new metrics. But I think in the near future, we'll be able to calculate metrics over a given tile and change those metrics in real time. So you'll be able to adjust the metric, see the tiles update immediately, and navigate around the world. And then similarly, we want to be able to do tile-to-tile joins. So instead of having to do joins where you extract some data and you keep all the joins in memory in the browser, we'll be able to basically just stick the tiles together on the fly, see the joins, calculate metrics over that joined tile sandwich, if you will, and very easily be able to do complex analysis over very large data sets without having to wait the extremely long query time that might sometimes be associated with this kind of analysis. So you can do this kind of thing using, distributed systems like Spark, but even in those cases, you're usually, it's usually not an interactive process. You're usually not able to adjust the metric on the fly, quickly see the results, navigate around the map, find the answers you're looking for. It's much more like a go and get coffee, wait for the result, iterate, go and get some more coffee. It's a very tedious process when you're doing this, even in a large distributed system. With hex tiles, we can deal with only the data we care about. And so being able to do that tile sandwich on the fly is going to be a really exciting way to navigate through multiple data sets at once and get the answers you need. Thank you so much for your time. We're going to have a Q&A session after this. And after the Q&A session, we'll go to Slack. Sorry, I'm stealing some of your thunder there, Miriam. But if you want to try out hex tiles, I'd encourage you to go to Unfolded Studio. There's a link here. You can look at our catalog where we have a lot of freely available hex tile data sets that you can play around with. You can join our Slack channel. There's a link on our site, or you can use the link that's here on the slides. Or you can email us if you're interested in learning more about this exciting new technology. We'd love to talk to you about it. Thank you so much.
Yay! I will be the crowd going wild sound effect here. So thank you, Nick. That was awesome to see the demos, both of kind of just hex tiles generally, and then how you can actually use them for site selection. So thank you again for giving us that walkthrough. And yes, as Nick mentioned, we're now kind of going into a Q&A session. So for folks, we have 2 questions so far, but for everyone else on the line, please feel free to start populating additional questions that you might have for Nick. And then immediately following this, we'll also invite everybody over to kind of, join us on Slack if you want to dig into more details or chat directly with Nick too. But yeah, we can get kicked off with the questions that we do have. So our first question for you, Nick, is can you use hex tiles with a maps control like leaflet or Mapbox?
So at the moment, you can only use hex tiles within Unfolded Studio, but Unfolded Studio has its own, JavaScript SDK. It has a Python SDK, so you can pretty easily integrate our maps with your product, and you can use hex tiles in that context. So you can use hex tiles with an embedded unfolded map. You can use hex tiles with an unfolded map that you control from your own web application. Please get in touch if you want to check out these technologies, or you can read more about the SDKs in our documentation site, which I should have put here, but it's docs.unfolded.ai.
Cool. Awesome. And I don't know if you guys are seeing also the chat. I put a little link to the hex tiles documentation there, so you should be able to navigate to the SDK documentation as well. Awesome. Our next question is about, so with regards to census information, are hex tiles normalized by census data, i.e. like income? So each hex tile represents a normalized income rates related to income rate per standardized geography, income per census block group, etc. So curious about that.
Yeah. So yes, the census hex tiles we put together, what we've done basically is to take the census reporting by, I believe, block group. Don't quote me on that, it could be block. And we break it up in a normalized fashion across hexagons, weighting by a couple different factors. So, you can think of this as a disaggregation mechanism in many cases, where we're disaggregating a block group into hexagons. We take into consideration a building layer. So we give basically more weight where there are buildings, because we figured that that's what the census data is representing, people in buildings. And we cut out water and a few other things from the data. But mostly what we're doing is sort of breaking up a somewhat weighted version of the census data across hexagons. So we've done this sort of normalizing and prep to try to give a pretty good representation hexagon by hexagon of the original census data. As I said in the original presentation, it's an abstraction. It's not going to be perfect, but I think we've done a pretty good job of giving a good representation of the census data across the H3 grid.
Awesome. For our next question, I like the format of it. Is the following statement true? If it's just for visualization, vector tile is enough, whereas for analytical purposes, hex tiles is a better choice.
That is a good question. I am inclined to say yes. In many cases, it would be sufficient to visualize data with vector tiles. The parts that I think we could offer there, one is that it's very hard to make your own vector tiles unless you are, a software engineer or maybe a GIS professional. Making your own vector tiles and serving them can be quite difficult, whereas making your own hex tiles can be quite simple, especially when we add the UI that will be coming soon, where you'll be able to turn your data set into hex tiles. The other piece here is just from a technical standpoint. While vector tiles are going to give you a higher level of accuracy about the shapes that you're showing, if you're interested in showing things across the H3 grid or across a grid system in general, then hex tiles might actually be more efficient and a more effective way of navigating through that data, just because they've got a pretty efficient rendering pipeline, and they have this sort of uniform cell concept, so you don't actually have to define every single outline of every single shape. If you're trying to show, maybe hundreds of thousands of individual cells in a vector tile, it can still actually be really difficult for a web map to show that, whereas it's fairly efficient to show it with hex tiles. So we think that they actually have some benefits from a visualization standpoint as well, even if that's the only thing you're using it for. But I think that they definitely have benefits, as you mentioned, for analysis, and I think that's where we feel that they really shine compared to vector tiles.
Awesome. Is there a plan to auto scale between H3 resolutions on Zoom and/or data scale?
I'm not sure if I totally understand the question. So we do auto scale on Zoom, essentially. As you probably saw when I was doing the quick demo. Let's see, I think I've hidden it now. I'm just demoing on the fly, which is never a great idea. But as you can see, we have fine-grained cells when we're zoomed in. We have coarse cells when we're zoomed out. Something we can do now, but we don't currently expose to the end users because we didn't want it to be too complicated, is that we can, you can have a slider that basically changes how coarse or fine your visual representation is. So which resolution of the tile set we bring in. So I'm not sure if this is the auto scaling that the asker was suggesting, but we do some of that now from a visual standpoint. And we do something similar from a data standpoint. So when we're making the hex tiles from a large data set, we're basically building a tile pyramid, which is a phrase you might be familiar with if you're familiar with web mapping in general, where we build many different layers from the finest to the coarsest, and we aggregate up as we go. So that's something that we do at tile creation time. Again, I'm not sure if that's exactly what's meant by auto scale here, but we're doing some of that right now when we create tile sets.
Cool. Awesome. And yeah, please chime in if that was not your question, but I think that makes sense. I have two questions that are kind of similar, so just kind of tying them together. And then for folks, I know we're technically at time, we're just going to keep going with a little more Q&A, but if you have to hop off, we hope we'll see you kind of at the Slack chat in just a little bit. But yeah, just to kind of end with maybe this question, and then we can hop over to Slack. So one question is, will hex tile or vector tile come to Kepler? I don't know if you know that, Nick. And then the other question is it intended to open source the technology behind hex tiles tiling system? If you want to talk a little bit about that.
Sure, great questions. They probably do go together, and then I don't imagine we'd be able to put hex tiles into Kepler without open sourcing some parts of the work that we've done here. The caveat here is that I can't say for sure. It's, as they say, it's above my pay grade to say whether we're actually going to open source it. I think that the first target, and this is something that we are reasonably sure we'd like to do, is to open source the format. So to open source the structure of the tiles themselves, to explain why we think that this is a good format, and make it an open standard. And that would allow everyone to create their own hex tiles using whatever technologies they would prefer. The main reason we haven't done that yet is because I think it's most useful to open source something that actually, particularly for standards, they have to be relatively well baked. You know, you have to have it relatively firm. There are still changes we're making now as we do active development on this technology, where we might not, you know, we wouldn't, if we had a standard, we'd have to do a major version change to implement that. Whereas if we keep it proprietary for the moment, we're the only ones who are affected by the changes. So I think there are good reasons to keep on iterating in a proprietary manner first, but long term, I would really like to see the standard at least be open. Along with that, I think that there's some chance, and I don't know for certain, but I think that there's some chance that we'd be able to open source some of the front end elements of this, and that would be what would be required to get this into Kepler. So we might open source some parts of the rendering pipeline. I don't think we would ever open source the back end, because it's an entire, you know, data pipeline system. Usually those things are hard to open source. They involve many different components, many different, you know, independent services, and you know, and that's a much harder thing to actually make public in a useful way. Even if we open source what we had now, probably no one would want to replicate the exact setup we have, because that's not usually how these things work. But I think definitely the front end components, there's some chance that we would do so in the future. Unfortunately, as I said, I'm not in a position to promise that, but I can say that it's something that I would like to see as well.
Awesome. Well, thank you, Nick. And we do have, there's a bunch more questions, but I think what I might do is wrap our live Q&A for now, and then I'm going to just post in the chat, so hopefully y'all just saw that. We'd love to just keep the conversation going on Slack, so if you kind of go to our sign up link there for our community Slack, that'll get you in. It's also just a great resource for questions generally, like if you're getting started with Unfolded or hex tiles. It's filled with hundreds of geospatial enthusiasts, so we're pretty active as well. So, you know, staff members chime in, fellow users chime in. It's just a good place to get help in general. And what we'll do is we'll actually just go through the additional questions that we didn't get to in our webinar today. So if you didn't get your question answered, definitely check back on that on the Fireside chat channel within the Unfolded Slack workspace, and we'll have your answer there. But thank you so much, Nick. We really appreciate your time. And we'll also I'll give a shout out as well to Isaac Brodsky, who is the fellow co-creator, fellow mastermind with Nick on both H3 and hex tiles. The entire Unfolded team, of course, was behind this launch, but he's another kind of key player in it. So we're very grateful for your love of hexagons and bringing this kind of new technology to the world. So thank you again.
Thanks so much.
Thanks, everybody, and we'll see you on Slack in about 10 minutes. Bye, all.